session in mathematics. In this session, we'll be dealing with matrices on the application of matrices to solving simultaneous equations. But before that, let us take a review of our previous lesson. Welcome back. We'll be looking at what? Application of matrices to solving simultaneous equation. And in using matrices to solve simultaneous equation, we have two methods, which are inverse method and then Cramer's rule. But in this study, we'll be dealing with inverse method. Then in our next class, we'll go over to Cramer's rule. Okay? So when you want to use inverse method to solve a problem in matrix which involves simultaneous equation, we'll always have a product to be of the form AIX plus B1Y equal to K1, and then we'll have A2X plus B2Y equal to K2. Now, if this is a 2 by 2 matrix, then we have our matrix to be matrix of A1, that's what it means, then B1, A2, B2 to be equal to K1 and K2. Do you understand? Now, these are the coefficient of what? X and what? Y. So the coefficient of the variable is what we use in solving this. If this is the case, what we've just succeeded doing is to form the matrix. Then after forming the matrix, we'll find the inverse of this matrix. We'll find what? The inverse of this matrix. Remember the method, inverse what? Method. We'll find the inverse of this matrix. Then when we find the inverse, we'll now multiply the inverse by the constant on the right hand side of the equation, which are K1 and K2. K1 and K2 are constants. Okay, so when you find the inverse, you now multiply the inverse by what? The constant on the right hand side of the equation. Then whatever it gives you are the values of X and Y respectively. Okay, am I making you more confused? Okay, don't worry, you understand that better. So let's take an example where I'll explain it more. Assuming we are given x plus 2y to be equal to 4 and 3x minus y to be equal to 5, and we are asked to solve this using inverse method. The first thing we need to do is to form what? The matrix. We form what? A matrix. How do we do that? This is our A1, right? This is our A1, this is our B1, this is our A2, this is our B2. So our A1, the coefficient of x here is 1, you write 1. Our B1, the coefficient of y is 2, you write 2. Our A2, our coefficient of x is what? Is 3. And then this, the coefficient of y is what? Minus 1. Right? And remember, what we multiply with this to give us this is what? X and what? And y. Is that right? Is that right? And then this is equal to 4 and what? 5. So we succeeded in forming what? The matrix. And then I told us that the first two, after we must have formed this, then we need to find what? The inverse. The inverse of the new matrix. Let's call it matrix A. The inverse of A. So if we find the inverse of A, I won't be solving that because I know we've really dealt with that. So the inverse of A, our A is 1, 2, 3 and minus 1. Our inverse of A means we need to find what? The minor first. By finding the minor, our minor will give us minus 1, 3, 2 and 1. Then we'll find the cofactor. I know you know how we got our answer to be this. The cofactor minus 1, minus 3, minus 2, and then 1. Okay, then after our cofactor, we then find the adjoint, which is the transpose of this, and that will give us minus 1 minus 3, and then minus 2 and what? 1. So we then find the determinant of A. And that will give us this is our A, 1, 2, 3, and minus 1. We'll multiply. So we have 1 times minus 1 to give us what? Minus 1. Then minus 3 times 2 is 6, which will give us minus what? 7. Minus 7. So we found our determinant, we found our adjoint. We then divide, because that is what we call the inverse. Inverse of A is equal to adjoint of A all over determinant of A. You remember? So let's go over. These are adjoint. We have minus 1, minus 2, minus 3, 1 all over minus 7. And that will give us minus 1 over 7 over minus 7, minus 2 over minus 7, minus 3 over minus 7, 1 over minus 7. And that will give us 1 over 7, because this will eliminate the minus, 2 over 7, 3 over 7, and minus 1 over 7. And that's our what? That's our inverse. So I told us now that the next thing we need to do is to multiply this inverse by the constant on the right hand side of the equation, which is 4 and what? 5. So we'll multiply by 4 and 5. Therefore we'll have 1 over 7, 3 over 7, 2 over 7, minus 1 over 7 into 4, 5. Okay, then we'll have you know how we multiply that, right? We have 1 over 7 times 4 plus 2 over 7 times 5. Okay, and then we have minus, we have 3 over 7 times 4 plus minus 1 over 7 times 5. So what do we have? 1 over 7 times 4 will give us 4 over 7 plus 2 over 7 times 5. 2 times 5 is 10 over what? 7. And then for this, what do we have? We have 4 times 3 is 12 over 7. And minus 1 times 5 will then give us minus 5 over 7. Okay, let's add them up. Taking the LCM of this, we have 10 plus 4 is 14 over 7. Then for this, the LCM also is 7. And then 12 minus 5 will give us what? 7. Is that correct? So we have 14 divided by 7, 2. 7 divided by 7 is what? Is 1. So at this point we have what? 2 and what? 1. So remember, we have here to be x and what? Y. So the values of x and y are what? 2 and 1. So x is equal to 2 and y is equal to 1. Okay, so that's a very simple way of solving this. Let's now go over to 3 by 3 matrix. 3 by 3 matrix. An example, if we have x plus 5y minus z equal to 8, 3x minus 2y plus 4z equal to 0, and then 2x plus y minus 2z equal to 7. First thing we need to do also is to form what? The matrix. So the coefficient of this is 1, this is 5, this is minus 1. Here we have 3, minus 2, 4, we have 2, we have 1, and then we have minus 2. Remember what we are dealing with is what? X, Y, and what? Z. And this is equal to 807. Okay, so we then find, let's call this our matrix B. We then find what? The inverse of B. Inverse of what? B. Okay, to find the inverse of B, first of all we need to find the minor, and I thought of how to do that, so I'll just be writing the product, the answer from the minor. The minor of B is equal to 0, minus 14, 7, minus 9, 0, minus 9, 18, 7, and minus 17. Then we'll find the cofactor of B, which is equal to 0, 14. Cofactor is just the change of what? Signs. Okay, so we have here to be 9, 0, 9, and we'll have 18 minus 7, then 7 minus 17. Okay, so this is the cofactor. Then we'll now find the adjoint, which is just a transpose. The adjoint of B is 0, 9, 18, 14, 0, minus 7, 7, 9, minus 17. Okay, then the determinant of the original matrix, determinant of B, is equal to 1, 5, minus 1, 3, minus 2, 4, 2, 1, minus 2. You know what we are doing here, right? So this is the original matrix, so that's what we are dealing with here. And then we have 1 into 4 minus 4 minus 5. You know how we do that, right? This is 1. You eliminate everything here, eliminate everything. So you have minus 2 times minus 2, which is 4, minus 4 times 4. That's how we got 4 minus 4. Okay, 4 times 1, which is 4. So that's how we got this. Then for 5, we eliminate this. You have 3 times minus 2, which will give you minus 6, minus 4 times 2 is what? Is 8. Do you understand now? So for 1, we have minus 1 into 3 minus minus 4, and then we have here to be 0, minus 6 minus 8 will give us minus 14 times minus 5, we have what? 70. Then for this we have minus 7, and that will give us 63. That's our determinant. So our inverse of B is then equal to adjoint over determinant. You know that already. So we have 0 over 63. We have 9 over 63, 18 over 63, 14 over 63, 0 over 63, minus 7 over 63, 7 over 63. We have 9 over 63 minus 17 over 63. Okay, and then what do we have? 0 divided by 63 is 0. 9 into itself is 1. 9 here is 7, so I have 1 over 7. Okay, then 9 can go into this to give us 2. Here is what? 7, so we have 2 over 7. Same thing here. 7 can go into this to give us 2. 7 go into this to give us 9. We have 2 over 9, and this is 0. Okay, 7 into itself is 1. 7 into 63 is 9. We have minus minus 1 over 9. Then here is 1 over 9. 1 over 9. And then we have 1 over 7. We have minus 17 over 63. So found the inverse of the matrix B. Let us now solve for what? The multiplication. Let's now go over to the last step, which is multiplying the inverse by the constant on the right hand at the right hand side of the equation. So let's write it down here. We have 0, 1, 7 and 2 over 7. 0, 1 over 7, 2 over 7. We have 2 over 9. We have 0, and then we have minus 1 over 9. We have 1 over 9. We have 1 over 7 minus 17 over 63, and this is times what? The number at the right hand side of the equation, which is 8, 0 and what? 7. So 8, 0, 7. And we all know how we run our multiplication. Is that correct? So the row multiplies the what? The column. Therefore we have 0 times 8 plus 1 over 7 times 0 plus 2 over 7 times 7. Is that clear? Then we have the second one, 2 over 9 times 8 plus 0 times 0 plus minus 1 over 9 times 7. Then for this we have 1 over 9 times 8 plus 1 over 7 times 0 plus minus 17 over 63 times 7. Okay, check their product. What do we have? 0 plus 0 plus what? 14 over 7. Then we have this to be what? 16 over 9 plus 0 minus 7 over 9. And then what do we have on the other one? We have 8 over 9 plus 0, and then minus 119 over 63. And what would that give us? This is 14 divided by 7. We have 2. This is 16 over 9 minus 7 over 9. 16 minus 7 will give us 9. 9 divided by 9 is 1. We have 8 over 9 minus 119 over 63. So what's the LCM? 63. 9 into 63 is 7, and 7 times 8 will give us what? 56. Is that correct? Minus 119. So 119 minus 119 plus 56 will give us what? 63. But remember, it's a minus 63 all over 63, which will give us what? Minus 1. So this is minus 1. Okay, and it means invariably that these are the values of x, y, and z. X is equal to 2, y is equal to 1, and z is equal to minus 1. So thank you for being part of today's class. To refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to deal with inverse rule of matrix. In our next class we'll go over to Cramer's rule. So do well to use the lesson note on the platform for better information on what we've done, and feel free to leave your questions or comments on the comment section. Till we meet again, stay safe. Bye.